The LCM of the denominators of two rational expressions is also the least common denominator, or LCD, of the rational expressions. You can use the LCD to add or subtract the expressions. Recall how you use the LCD to add fractions. Well, in the case of 1/8 plus 1/10, well, 1/8 equals 1 over 2 to the third power, and 1/10 equals 1 over 2 times 5. Having written the expression this way, we can see that we have a 2 cubed in the denominator on the left, and a 2 to the first power in the denominator on the right. So what we're missing is 2 squared from the denominator on the right. So if we multiply the top and bottom by 2 squared, we're multiplying that expression by 1, but 1 written in a way that accomplishes work for us, 2 squared over 2 squared, in order to form a denominator of which 2 cubed is also a factor. Now 2 cubed, on the other hand, 2 cubed has a 2 as a factor, but it's missing a 5. So we would need to multiply the fraction on the left by 1 written as 5 over 5 in order to establish a common denominator. So the left expression, 1 over 2 cubed, is multiplied by 1 written as 5 over 5. That leads to 5/40ths. And the expression on the right, 1 over 2 times 5, is multiplied by 1 written as 2 squared over 2 squared, and that leads us to the fraction 4/40ths. We've now established a common denominator, 40, and we can add the numerators. 5 plus 4 is 9, so our final answer, 9/40ths. Problem 2, adding rational expressions. What is the sum of the two rational expressions in simplest form? State any restrictions on the variable. X over x minus 1 plus 2x minus 1 over x squared minus 3x plus 2. Well, first, factor the denominators. X minus 1 is already in its factored form, so it remains x minus 1. X squared minus 3x plus 2, on the other hand, factors nicely as x minus 1 times x minus 2. Then we'll rewrite each expression with the least common denominator. The expression on the left has an x minus 1 denominator, but it's missing an x minus 2 factor. That's what the denominator on the right has, that the denominator on the left is missing. So we'll multiply the expression on the left by 1, but 1 written as x minus 2 over x minus 2 to account for that missing factor. Multiplying, the expression on the left becomes x squared minus 2x over x minus 1 times x minus 2. Now we have a common denominator, x minus 1 times x minus 2, and so we bring down the expression on the right, that's 2x minus 1 over x minus 1 times x minus 2. Now that we have a common denominator, we simply add the numerators and combine like terms. Now the numerators added together, that's x squared minus 2x plus 2x minus 1. Combining like terms, the numerator becomes x squared minus 1, still over that common denominator, x minus 1 times x minus 2. Now we factor the numerator. We want both the numerator and denominator in their fully factored forms so that we can reduce, if possible, and simplify our expression. The numerator, a difference of squares, factors nicely as x minus 1 times x plus 1. And note, now we have an x minus 1 factor in both the numerator and denominator, so we can divide out those common factors, and we're left with the simplified version of the expression, x plus 1 over x minus 2. However, we do need to account for the restriction on the domain, or on the x value. X cannot equal 1. Recall that would lead to a 0 denominator based on the factor that we divided out, x minus 1. And now we state, in our final answer, the sum of the expressions is x plus 1 over x minus 2, for x does not equal 1, and also x does not equal 2. Your turn. What is the sum of the two rational expressions in simplest form? State any restrictions on the variable. Part A, x plus 1 over x minus 1 plus negative 2 over x squared minus x. Part B, x over x squared minus 4 plus 1 over x plus 2. And part C, a reasoning item. Is it possible to add the rational expressions in problem 2 by finding a common denominator, but not the least common denominator? Explain.